We're going over Leetcode 73.3 flood fill. The image is represented by a 2D array of integers, each integer representing the pixel value of the image. Given our coordinates representing the starting pixels, row and column of the flood fill, a pixel value, new color, flood fill the image. To perform flood fill, consider the starting pixel plus any pixels connected 4 directionally to the starting pixel of the same color as the starting pixel, plus any pixels connected 4 directionally to those pixels, also with the same color as the starting pixel. It's a little bit confusing here, but we'll look at it later. So install and replace the color of all the aforementioned pixel with the new color. At the end, return the modified image. So if our input image is like this, you write it here. If it's like this, and for 2D arrays, you can like format it like this to make it easier to look at. Yeah, so if this is our input array and source row, source column is 1, 1, so row 1, column 1, this number, we have to change it to new color. So it was originally color 1, but we have to change it to color 2, our new color. And we have to change change any pixels connected 4 directionally to the starting pixel of the same color as the starting pixel. So remember, our starting pixel's color is 1, and so 4 directionally. So 1, 2, 3, 4. We may change them, but plus any pixel connected 4 directionally to the starting pixel of the same color as the starting pixel. So because this 2 colors is the same as our starting pixel color. Remember, it was 1, right? So we can change that to the new color. But for those that doesn't have the same color as our starting pixel, 1 doesn't get changed. Okay, after that, plus any pixel connected 4 directions to those pixels, also the same color as the starting pixel. So after we change this this color to 2, we also have to change its 4 directionally connected pixels. So 1, 2, 3, 4, but it's out of range, so it doesn't change that. We also have to change it to 2. For this, we also have to change its 4 directional, so change this to 2. Yeah, these 2 numbers doesn't get changed because it doesn't have the same starting color, which is 1. This color doesn't get changed because it's not adjacent. It's not like 4D directionally adjacent to any of those eligible pixels. So yeah, this is how it works. So you can see that we first change our source row, source column color to the new color, and we change its like 4 directional color. And after that, we also change recursively change whatever we've changed to the new color. So you can see that obviously we have to use recursion to solve this problem. Okay, so let's just code it up, I'll explain you. So first of all, so if our if our new color is the same as our source row, source column color, we just return our original image. That's a corner case. So if our old color is so if our new color is the same as our old color, we just return our original image. Then we have to write a function, recursive function, right? Let's call it change. and it takes a row and a column. So for the recursive function, our base case is going to be if our row and column is out of the range of the 2D array, or if the row and column like a pixel is not does not have the same color as our old color. So if the row is out of our 2D array, or row, let's actually write, so the row is gonna be length of the image is gonna be how many rows we have in the original 2D array. C is gonna be how many columns we had in our 2D array. So if it's like out of our 2D array, or if the color is not the same as our old color, so that's our base case. We just return image. Otherwise, we have to change. Otherwise, it's like within the 2D array, and also the color is same as the old color, so we have to change it into our new color, right? So after that, we also have to change. It's like 4 directional pixels. So we do the recursive call. So we change the what's like down to our image. What's up to our image, what's like down to our pixel, what's